The Disappearing Spoon, Chapter 2, The Fathers of the Periodic Table. You may say the history of the periodic table is really the history of the many people who shaped it. Just as some of the elements of the periodic table are better known than others, many of the names of the scientists who discovered them and who arranged them into the first periodic tables are famous, while others have long since been forgotten. Bunsen, Mendeleev, and Meyer. One name from the periodic table's history that you may recognize is Robert Bunsen. This pioneer of the periodic table deserves special praise, since you've probably used a piece of school lab equipment named after him. Disappointingly, the German chemist didn't actually invent his Bunsen burner, but rather improved on the original design in the mid-1800s. Bunsen's first love was arsenic, one of the most poisonous elements on the periodic table. Although element 33 has had quite a reputation since ancient times, Roman assassins used to smear it on figs and wait for their targets to eat, few law-abiding chemists knew much about arsenic before Bunsen started sloshing it around in test tubes. He worked mainly with arsenic-based cacodyls, chemicals whose name is based on the Greek word for stinky. Cacodyls smelled so foul, Bunsen said, that they made him hallucinate. His tongue became covered with a black coating. Perhaps from self-interest, he soon developed what is still the best antidote to arsenic poisoning, iron oxide hydrate, a chemical related to rust that clamps onto arsenic in the blood and drags it out. Still, he couldn't shield himself from every danger. The accidental explosion of a glass beaker of arsenic nearly blew out his right eye, leaving him half blind for the last 60 years of his life. Following the accident, Bunsen put arsenic aside, and after investigating geysers and volcanoes for a while, he settled back into chemistry at the University of Heidelberg in the 1850s. There he invented the spectroscope, a piece of lab equipment that uses a prism and light to study elements. Each element on the periodic table produces sharp, narrow bands of colored light when heated. Hydrogen, for example, always emits one red, one yellowish green, one baby blue, and one indigo band. If you heat some mystery substance and it emits those specific lines, you can bet it contains hydrogen. This was a powerful breakthrough, as it was the first way to peer inside exotic compounds without boiling them down or disintegrating them with acid. The only thing limiting spectroscopy at that point was getting flames hot enough to excite elements. So Bunsen created the device that made him a hero to everyone who ever melted a ruler or set a pencil on fire in a school chemistry lab. Bunsen's work helped the periodic table develop rapidly for two reasons. First, the spectroscope allowed new elements to be identified. Second, and just as important, it helped sort through many claims for new elements by finding old elements in disguise in these unknown substances. But beyond finding new elements, scientists needed to organize them into a family tree of some sort. And here we come to Bunsen's other great contribution to the table. At Heidelberg, he instructed a number of people responsible for early work in periodic law. This includes our second character, Dmitri Mendeleev, the man often referred to as the father of the periodic table. All the scientists working on early periodic tables recognized likenesses among certain elements, but some scientists were better than others at recognizing those similarities. Knowing how to recognize and predict such similarities soon enabled Mendeleev to create the first real periodic table. Truth be told, like Bunsen and the burner, Mendeleev didn't conjure up the first periodic table on his own. At least 6 people invented it working independently, but Mendeleev became the most important character in the story of the periodic table. Born in Siberia, the youngest of 14 children, Mendeleev lost his father in 1847 when he was 13. Boldly, his mother took over a local glass factory to support the family, but the factory soon burned down. Pinning her family's hopes on her smart young son, she bundled up Dmitri on horseback and rode 1,200 miles across the mountains of Russia to an elite university in Moscow, which rejected Dmitri because he was born in a rural place. Undaunted, Mama Mendeleev bundled him back up and rode 400 miles farther to his father's old college in St. Petersburg. Just after seeing him enrolled, she died. Luckily, Mendeleev proved to be a brilliant student. After graduation, he studied in Paris and Heidelberg, where Bunsen supervised him for a spell. The two clashed personally, partly because Mendeleev was moody and partly because of Bunsen's notoriously loud and foul-fumed lab. Mendeleev returned to St. Petersburg as a professor in the 1860s and there began to think about the nature of elements, work that would culminate in his famous periodic table of 1869. Many others were working on the problem of how to organize elements, and some even solved it. In England, a chemist named John Newlands presented his makeshift table to a chemistry society in 1865. At the time, no one knew about the noble gases, helium through radon, so the top rows of his periodic table contained only 7 units. Newlands compared the 7 columns to the do, re, mi, fa, sol, la, ti, do of the music scale. Unfortunately, the Chemical Society of London thought this was a bit too childish, and Newlands was laughed at. The more serious rival to Mendeleev was Julius Lothar Meyer, a German chemist with an unruly white beard and neatly oiled black hair. Meyer published his table at practically the same time as Mendeleev, and the two even split a prestigious pre-Nobel Prize called the Davy Medal in 1882 for co-discovering the periodic law. While Meyer continued to do great work that added to his reputation, Mendeleev turned cranky and, incredibly, refused to believe in the reality of atoms and other things that he couldn't see, such as electrons and radioactivity. If you had sized up the two men around 1880 and judged who was the better chemist, you might have picked Meyer. So, what separated Mendeleev from Meyer and the other chemists who published tables before them? Unlike others who had tried arranging elements into columns and rows, Mendeleev had worked in chemistry labs his whole life and had a deep, deep knowledge of how elements felt and smelled and reacted, especially metals, the most difficult elements to place on the table. This allowed him to accurately place all 62 known elements into his columns and rows. Most important of all, while both Mendeleev and Meyer left gaps on their table where no known elements fit, Mendeleev, unlike Meyer, predicted that new elements would be dug up. Mendeleev even predicted the densities and atomic weights of hidden elements, and when some predictions proved correct, people were mesmerized. Furthermore, when scientists discovered noble gases in the 1890s, Mendeleev's table passed a crucial test since it easily incorporated the gases by adding one new column. Mendeleev threw together his first table to meet a textbook publisher's deadline. He'd already written Volume 1 of the textbook but had covered only 8 elements. This meant he had to fit the rest into Volume 2. After 6 weeks of procrastinating, he decided in one inspired moment that the most concise way to present the information would be to arrange them in a table. In it, Mendeleev not only predicted that new elements would fit into empty boxes beneath the likes of silicon, element 14, and boron, but also provisionally named those elements. He used an exotic language to create those names using eka, the Sanskrit word for beyond. As a result, the elements, eka-silicon, eka-boron, and so on, were born. Overall, Mendeleev's work in chemistry is comparable to that of Charles Darwin's in biology and Albert Einstein's in physics. None of those men did all the work, but they did the most work, and they provided more proof than others. They saw how far the consequences extended and backed up their findings with lots of evidence. And like Darwin, Mendeleev made lasting enemies because of his work. Naming elements he'd never seen was presumptuous, and doing so infuriated the man who discovered eka aluminum and justifiably felt that he, not the Russian, deserved credit and naming rights. Paul-Émile Lecoq de Bois-Badron was born into a winemaking family in the Cognac region of France in 1838. He moved to Paris as an adult, mastered Bunsen's spectroscope, and became the best spectroscope scientist in the world. In 1875, after spotting never-before-seen color bands in a mineral, Lecoq de Bois-Badron concluded instantly and correctly that he discovered a new element. He named it gallium, element 31, after Gallia, the Latin name for France. Some accused him of slyly naming the element after himself, since le coq, or the rooster, is gallus in Latin. It took a few years, but by 1878 the Frenchman had produced a nice, pure hunk of gallium. Though solid at moderate room temperature, gallium melts at 84 degrees Fahrenheit, meaning that if you hold it in the palm of your hand, it will melt, because body temperature is about 98 degrees Fahrenheit. It's one of the few liquid metals you can touch without boiling your finger to the bone. As a result, gallium has been a staple of practical jokes. Since gallium molds easily and looks like aluminum, one popular trick is to fashion gallium spoons, serve them with tea, and watch people freak out when their spoon disappears into their drink. Lecoq de Bois-Badran reported his discovery of gallium in scientific journals. It was the first new element discovered since Mendeleevs' 1869 table, and when the Russian read about it, he tried to claim credit based on his prediction of Eka aluminum. The Frenchman and Russian began debating the matter in scientific journals, and before long the discussion turned nasty. Annoyed at Mendeleevs' moaning, Lecoq de Bois-Badran claimed an obscure Frenchman had developed the periodic table before Mendeleev and that the Russian had stolen this man's ideas, a scientific sin. For his part, Mendeleev claimed that Lecoq de Bois-Badran must have measured something wrong because the density and weight of gallium differed from his own predictions. Lecoq de Bois-Badran soon retracted his data and published results that matched Mendeleev's predictions. According to science philosopher-historian Eric Scarry, the scientific world was astounded to note that Mendeleev, the theorist, had seen the properties of a new element more clearly than the chemist who had discovered it. The interesting debate here is theory versus experiment. Had theory turned Lecoq de Bois-Badran's senses to help him see something new, or had experiment proved the real evidence and Mendeleev's theory just happened to fit? Although Lecoq de Bois-Badran denied that he had ever seen Mendeleev's table, it's possible that he had heard of others or that the tables had gotten the scientific community talking and had indirectly alerted scientists to keep their eyes peeled for new elements. As no less a genius than Albert Einstein once said, "It is theory that decides what we can observe." Of course, Mendeleev made many wrong predictions too. He was lucky, really, that a good scientist like Lecoq de Bois-Badran discovered Eka aluminum first. If someone had poked around for one of his mistakes, Mendeleev predicted that there were many elements before hydrogen and swore the sun's halo contained a unique element called coronium, the Russian might have died in obscurity, but people tend to remember only Mendeleev's triumphs. Moreover, when simplifying history, it's tempting to give Mendeleev too much credit. He did a lot of the important work, but in 1869, only 2/3 of all elements had been discovered, and for years some sat in the wrong columns and rows on even the best tables. Ytterby, an element gold mine. Loads of work separates a modern periodic table from Mendeleev's, especially one of the rows at the bottom of the table, the lanthanides. The lanthanides started with lanthanum, element 57, and their proper home on the table baffled chemists well into the 20th century. Even Mendeleev, who wasn't shy about predictions, decided that the lanthanides were too difficult to deal with. After cerium, element 58, he dotted his table with row after row of frustrating blanks, and later, while filling in new lanthanides after cerium, he often got their placement wrong, partly because many new elements turned out to be combinations of already known ones. Mendeleev could have resolved all of his frustrations had he traveled a few hundred miles west from St. Petersburg. There in Sweden, near where cerium was first discovered, he would have come across a nondescript mine in a coastal village with a funny name, Ytterby, pronounced Itterby, and meaning outer village. The Itterby quarry supplied fine raw ore for porcelain and other purposes. More interestingly, for scientists, its rocks also produced exotic pigments and colored glazes when processed. Nowadays, we know that bright colors are dead giveaways of lanthanides, and the mine in Itterby was unusually rich in them for geological reasons. The Earth's elements were once mixed uniformly in the crust, as if someone had dumped a whole rack of spices into a bowl and stirred it. But metal atoms, especially lanthanides, tend to move in herds, and as the molten earth churned, they clumped together. Pockets of lanthanides happened to end up near, actually beneath, Sweden. But while Ytterby had the proper geology to make it scientifically interesting, it still needed some great scientists to discover its treasures. The most important man in the discovery of the lanthanides was Johann Gottelin. Born in 1760, Gottelin was a chemist in a line of scientific-minded academics. After extensive travel in Europe as a young man, Gottelin settled down in Turku, in what is now Finland, across the Baltic Sea from Stockholm. There he earned a reputation as a geochemist. Amateur geologists began shipping unusual rocks from Ytterby to get his opinion, and little by little, through Gattelin's publications, the scientific world began to hear about this remarkable little quarry. Although he didn't have the chemical tools or chemical theory to tweeze out all 14 lanthanides, Gottelin made significant progress in isolating clusters of them. He made element hunting a pastime, and when, in Mendeleevs' old age, chemists with better tools revisited Gattelin's work on the Ytterby rocks, new elements started to fall out like loose change. Gottelin had started a trend by naming one supposed element, yttria, and in recognition of all the elements' common origin, chemists began to immortalize Ytterby on the periodic table. More elements' names, 7, trace their lineage back to Ytterby than to any other person, place, or thing. It was the inspiration for ytterbium, element 70, yttrium, element 39, terbium, element 65, and erbium, element 68. For the other 3 unnamed elements, before running out of letters, erbium doesn't look quite right, chemists adopted holmium, element 67, after the Latin name for the Swedish capital, Stockholm, thulium, element 69, after the mythic name for Scandinavia, and, at Lecoq de Boisbaron's insistence, gadolinium, element 64, after Johann Gottelin. Overall, of the 7 elements discovered in Ytterby, 6 were missing lanthanides. History might have been very different. Mendeleev reworked his table constantly and might have filled in the entire row after cerium by himself, if only he'd made the trip west across the Gulf of Finland and the Baltic Sea.